Okay, let's look at the homework 3.6, 3.7, number 10. Right? So we want to sketch the graph of f of x, which is x to the fourth minus 2x squared. Right? So let's do that. First, we're going to find the x-intercepts and y-intercept. Right? So if you want to find x-intercepts, right, x-intercepts. Right, so what we need to do is first we're going to set y equal to 0. Right, so we basically set this whole thing equal to 0. So you have x to the fourth minus 2x squared equal to 0. Right? Then we're going to factor things out. Let's see what's in common. X squared is in common. Alright, so if you factor x squared from x to the fourth, x squared. And x squared from negative 2x squared is negative 2. Right? And actually, we can factor this out. This 2 is square root of 2 squared. So this is going to be x squared. And you can probably write it as x plus square root of 2 times quantity x minus square root of 2. Right? Set that equal to 0. Right? Which will give you x-intercepts. Let's see. So from here, you can see that it's 0. Right? And from here, you have negative square root of 2. And from here, you get positive square root of 2. Right? So let's type that in. Right? So it's going to be 0, comma, and the y is 0, of course. So we have that. And square root of 2. So the square root of, oh, actually, smallest x value, sorry. So I have to put the negative square root of, square root of 2, right? Comma, 0. And the next one would be 0. So I have to delete that one. 0, comma, 0. And the next one is square root of 2, comma, 0. Right? So those are the x-intercepts, and find the y-intercepts. Right? So we want to find the y-intercepts. Intercept is only 1. Right? So we set x equal to 0. Right? Which is going to be, right? So just to plug in 0 for x. But you can see that it's 0 to the fourth minus 2 times 0 squared is, of course, 0. Right? So it's going to be x is 0 because it's a y-intercept, and we found that it's also 0. Right? Then we want to find the relative max and the relative min. Right? So let's do that. Right? So we want to find the local extrema. Right? So we just need to do a number line here. So we're going to do a number line. Right? Critical numbers are, so let's see. Oh, so sorry, we have to take the derivative first. Maybe right? So first we take the derivative, f prime of x, right? Just a power rule, so it's going to be 4x subtract 1 from the power, so it's cubed, right? So negative 4 x and to the first power, right? So factor out 4x, you have x squared from the first term and minus 1 from the second term, right? Then since this is the difference of squares, we can factor it out a little further. So it's going to be x plus 1 times quantity x minus 1, right? Set that equal to 0, right? So you can see that critical numbers are x equals, from here is 0, right? From here is negative 1 and positive 1, so it's a plus or minus 1, right? So these are critical numbers, right? Then we just have to do a number line here, right? So you have 0 and negative 1 and positive 1, right? So let's look at the sign of f prime, right? So we can try something smaller than negative 1. So it's x equals, say, negative 2, right? So plug it in. So if you look at that, right, if you plug in negative 2 here, so that's going to be negative. And negative 2 plus 1 is still negative, right? Negative 2 minus 1 is negative, right? Negative times negative times negative is negative. So it's negative here. Right, so between negative 1 and 0, so we can try x equals negative 1/2, right? So if you plug in negative 1/2 here, so 4x would be negative, right? Negative 1/2 plus 1 is positive, right? Negative 1/2 minus 1 is negative, which means that negative times negative is positive, right? We can try between 0 and 1. So we can try 1/2. So x equals positive 1/2. Right? So 4x is positive. X plus 1 is positive. Right? 1/2 minus 1 is negative. So positive times negative is negative. Right? So we can try any number bigger than 1. So I'll try 2. Right? Then what you get is 4x is positive, 2 plus 1 is positive, 2 minus 1 is also positive. So everyone is positive. So this is positive here. All right. So we can use the first derivative test. So you can see that it's a decreasing. So f is decreasing here. And maybe I'll draw an arrow, so it's decreasing here. After that, it's increasing here. After 0, decreasing here. After that, increasing here. Right? So you can see that there's going to be a minimum, so here, and maximum here using first derivative test. And here you have a minimum here. Right? So let's see, we just have to find the corresponding y value or function value, so plug in negative 1. If you plug in negative 1 into the original function, so it's negative 1 to the 4th power minus 2 times negative 1, which is going to be, so 1 plus 2, so it's 3, right? F of 0, we actually done that, so that's 0. And f of positive 1 is going to be 1 to the 4th, which is 1, minus 2 times 1 squared. Oh, actually, I messed it up. This is square. So this is actually 1 minus 2, so it's negative 1, right? And this is the same, it's negative 1, right? So let's type it in. Right, so relative max would be at 0, 0. And relative min was negative 1. Oh, actually, we have to do a smaller, so it's negative 1, comma, negative 1. And larger 1, so it's x 1, comma, negative 1. Right, so those are the local minimum. Right, then points of inflection. So let's find that. Right, so there's no room, so I'm going to just erase this. Alright, so we know that, oops, I need to know the derivative here. So derivative was f prime of x was 4x cubed minus 4x. So we take another derivative. So second derivative is going to be 3 times 4 is 12 x squared and minus 4. Right, so factor out 4. You have 3x squared minus 1. Right, if you set this equal to 0, right, so we basically need to solve 3x squared minus 1 equal to 0, right? Then basically dividing by 4, right? Then we add 1 to both sides. So 3x squared is equal to 1, right? I guess I have to go down here. All right, and divide through by 3. So that will give us x squared is equal to 1 over 3. Then we can take the square root of both sides. So x is going to be equal to plus or minus square root of 1/3, right? So we need to plug it in. So we need to make sure that there's concavity change. So we do the number line here, right? So it's negative square root of 1/3 and positive square root of 1/3, right? Then we look at the second derivative, right? So if you try something bigger than, a little smaller than negative square root of 1/3, I'll probably try negative 1. If you plug in negative 1 here, so 3 minus 1, so that's positive. Right here, between negative square root of 1/3 and the positive square root of 1/3, so we can probably try 0. I like 0. And if you plug in 0, so it's going to be negative. Then any number bigger than square root of 1/3, I'll probably try 1. Again, it's 3 minus 1, so that's positive. Right, so there's a concavity change because you have concave up here and a concave down here and a concave up here. So there's a concavity change. So there's going to be an inflection point here and also inflection point right here. Right? So we just need to find the corresponding y value. So f of square root of 1/3 would be, all right, so you have raise it to the fourth, square root of 1/3, raise it to the fourth power, minus 2, square root of 1/3, raise it to the squared, right? So that's going to be, all right, so you have square would be 1/3 and square again, so it's going to be 1/9 minus, right, square, so it's at 2/3, right? So taking the common denominator, which is 9, so it's 1 minus, right, 2/3 is same as 6/9, so it's going to be negative 5/9, right? And f of negative square root of 1/3, right? You can see that it's even power, so it's going to give you exactly the same number. So I'm going to just go ahead and write this. So you have a negative 5/9 because the negative sign is not going to matter. All right, so let's type it in. All right, so points of inflection is negative square root of 1/3. All right, comma, negative 5/9. And the other one is positive square root of 1/3, comma, negative 5/9, right? So you can't see that up here. All right, so those are the inflection points. All right, so let's find the horizontal asymptotes and the vertical asymptotes. All right. So let's find the horizontal asymptote, right? But you can see that here, this is just a polynomial function, and this guy does not have horizontal asymptote, so there's none, or it does not exist. And vertical asymptotes, again, we cannot make this guy blow up with the finite x value, so there's none. All right, so go back and type that in. All right, so probably it does not exist. Yeah, DNE. All right, type it in. Does not exist there. And here also does not exist. All right, then we need to sketch the graph of the function. All right, so let's look at that. All right, so based on these guys, we're gonna sketch the graph. All right, so let's see. So we're gonna just try to sketch the graph. All right. So we need to look at the first derivative, and it was, let's see, if we remember, it was going down and going up, going down and going up, and we're going through 0, 0, which is the origin. All right, and I think the other local max and local minimum, I believe, here is -1, -1, and a 1, -1. So we have to go through there. So you have here, so it's -1, -1. And +1, comma, -1. So we have to go through there. All right, then we have to, so going down, going up, going down, and the concavity is, so inflection point is negative square root of 1/3, and it's -5/9. So it's got to be somewhere over here, -5/9. And the same thing with the positive square root of 1/3. Right? So you can see that you're going to have a concave up shape here and concave down shape between here and a concave up shape and like that. And x-intercepts are, I forgot, x-intercept is plus or minus square root of 2. So you can go back. So this is going to be square root of 2 here, and this is negative square root of 2 there. All right, so let's find the correct picture. So the correct graph would be, let's see, this is probably the one, so we'll check that. All right, let's check the answer. Okay, it came back and looks like we got them all correctly. All right, that's it. I hope that this was clear.